and welcome to SGN Tech Forum. Today we are going to solve a real world challenge, that is, if you are a business owner or an application provider, unless you append HTTPS to make sure the application is secure, you are not trusted within internet. So how you can achieve that? In this video, we are going to focus on AWS solution, that is AWS certificate manager. However, that is not the only option. We'll talk about other options as well as we progress in the video. So before we get started, I would like to do a level setting here. That means what you should know. You should know at least two things, which is first is what is a digital certificate, and for that you can go to SGN Tech Forum and watch this video. Here I'm talking about how a digital certificate works and how it secure client and server communication. The second thing which is good to know is how the DNS actually work, right? Because when you are implementing a certificate, you will also playing with the DNS a little bit, so it's good to know how DNS functions. All right, so let's go back to our agenda. And as you can see, this is essentially what we are going to do. We have a VPC. Within that VPC, we have a public subnet. And within that public subnet, we have an EC2 instance serving an application on port 80, right? That means anyone from internet can connect to that application. If they have IP address or domain name, they can connect to that application, but that's not secure connection because port 80 doesn't use encrypted channel. So what are your options? So this is the baseline internet to from internet to AWS internet gateway, which connects you to your server. What you can do, you can use Amazon certificate manager as shown in previous screen here. So you can go to ACM and request a certificate for your application, and then you can either import that application directly on your server, but to do so you need some kind of proxy server, or the easiest way is assume you are running some kind of load balancer uh, to load balance your application. Then what you can do, you can import the certificate directly to your load balancer, so that anyone from internet, they'll make a connection, secure connection to your uh, load balancer. They'll be served a certificate on behalf of your server via load balancer, and behind the scene this link is load balance, given how many number of servers you are running, right? But if you are not using load balancer, then what are your option? You can still go ahead and request certificate from ACM, and then you have to run some kind of proxy service on this server that can redirect the incoming connection to your application. And there are two popular proxy services, Apache or Nginx, that can listen on port 443 for your incoming connections. All right, so things to remember: use AWS ACM certificate manager to request the public trusted certificate for your application. We are assuming that your application is public facing, so request a a trusted certificate. Then what you can do, use AWS Route 53 for DNS resolution. This is not mandatory. You can still use your DNS provider's name server, and that's why I said that DNS know-how of DNS is useful. So you can either use Route 53 or you can use your DNS provider. Route 53 has its own advantage because it's distributed and can be really fast resolution. Once this is done, you can import the certificate on AWS supported solution like ELB or CloudFront. We just talked about that. Optionally, if you are not using any of the integrated services, then you can run a proxy service on the server to use that certificate. All right. So with that, let's go to AWS documentation quickly. What is AWS Certificate Manager? As you can see, it is a provider of public and private SSL TLS X509 certificate, and keys that protect your AWS website and application. So we are not going into much detail into certificate and what goes into that. For that, you can go back to that video and watch that. All right. So ACM certificate characteristics. Public certificate that you request through ACM are obtained from Amazon Trust Services and Amazon Managed Public CA. So Amazon, this is Amazon's public CA. That means most of the browsers and the devices, they have this CA trust store available. That means they trust anything signed by this CA. Then there are other details. Okay, so let's not go into that. Few things you need to know. Is it a regional service or which regions are supported? Because you may have distributed workload. To use the certificate with elastic load balancer for the same FQDN. So if you are using ELB, then you need to know few things. And if you are using integrated services like CloudFront, you need to know a few things. So please give it a read. All right, quickly look into the pricing. If you're not subject to any additional charges for SSL and TLS. So essentially you are not paying anything for your requesting certificate. You pay only for AWS resource that you create to run your website or application. In this case, if your application is running on EC2, then you pay for that, or you're using load balancers, then you pay for that. Right. Okay. Uh, we will be looking into setting up, register a domain. So you can buy a domain which can give you a FQDN for your application directly from Amazon, or you can go to any other provider like GoDaddy, Namecheap, or wherever you buy your domain. Then from there, you can come here and request certificate, issue and manage certificate. Requesting a public certificate, as you can see, you must use DNS compliant subject name. You must use this kind of private key algorithm and then the expiration date, etc. All right. And validate domain ownership. Here you can see we have two options. So suppose you are not using Route 53 to purchase your domain, you bought it from outside, still you can use ACM to request certificate. But that's the key thing is you need to prove your domain ownership. That means you need to prove that the certificate what you are requesting, say whatever xyz.com, you are the real owner for xyz.com. And for that there are two things: DNS validation or email validation. DNS validation is the quickest way to validate your ownership or prove your ownership, and this is very interesting how it is happening here, and you will see that when we actually request the certificate. But let me quickly tell you what exactly happening here. So you will go ahead and request a certificate. In turn, when you create the request, AWS will give you CNAMEs when you request the certificate. And you need to take this CNAME and go back to your original DNS provider and enter this CNAME. After that, AWS can query those CNAME, and once it sees that those CNAMEs are resolvable, that means they are available, it it knows that you have done your part and it's coming from the right provider who owns that domain, who has sold that domain to you. So this is pretty interesting chain of trust, how you can you can validate other provider from from AWS side. All right, with this, enough of talking. Let's go and request an AWS certificate. To do so, you have to go to your AWS console, search for ACM, and then we can say request certificate here, or you can say request certificate here. Right, it's essentially the same thing. What do you need? We need a public certificate. You can also request a private certificate, but that is a complete different workflow. Requesting a private certificate require a creation of private CA and all those things. but we are going to use AWS SCA. So let's go ahead and request a public certificate. So what do you need? You need a domain name, right? That's why you are here. You have a website. For that, you want a HTTPS certificate. So please come here and put your domain name. We have a test domain name. Uh, Let me show you how we are resolving that domain. Say, for example, we'll use dig ns.www.safely.in. This is one of the domain, and I want to show you how we are resolving this today. As you can see, we are resolving this using dyna.ns.net, not net. So dyne dot, that is the DNS provider, and it is one of their name server. So today this website is served via their name or resolved via the name server given from DNS provider. And I can show you real quick from going to the provider. As you can see, we have an IP address that is a EC2 instance, and we have created an A record for that in my provider, Dynadot, right? And we don't have anything else, no CNAME, nothing as of now. So let's go copy this domain. We want to request a certificate for this, and I'm going to say W. Okay, key algorithm 2048, which is good, or you can use ECDSA, which can take you to 3000 or 6000 size of the key. Let me say some kind of tag you can put, right? Let's, I cannot think of anything right now. So let's go ahead and simply request. That's the only information you need. You need your FQDN for your domain, and you need to select the validation method, which is DNS validation recommended, and email validation, which is a longer route. Choose this option if you authorize to modify DNS configuration for the domain in your certificate request. I do have access to manage the domain in my provider, so I'm going to choose this. Go ahead and say request. We are going to say, though there is no request, view all certificate. Okay, successfully requested certificate with ID this. A certificate request with the status pending validation has been created. Further action is needed to complete the validation and approval of the certificate. So we are going to go and view certificate. It's pending validation, and we know why, because we have to go ahead and populate this CNAMEs to our domain provider. Let's go ahead and complete the DNS validation. So at ACM, we have requested the certificate. In turn, we have got the CNAME, name, and value. And this name and value we need to create at our DNS provider, right? So let's do that and see in if in some time we can get the certificate issued and DNS validated. So as you can see, I have created this CNAME at my DNS provider. Save it, and we are going to wait for next 24 hours and make sure that this is getting validated. Okay, after some time, as you can see, this is still pending validation. I waited, so let's change the plan. Now we are going to use AWS Route 53 as our DNS. So for that, we are going to go ahead and create a DNS hosted zone on AWS and stop using my Dyn.aws provider. So today, or at this moment, as you can see, the domain name is resolved by initial domain provider. Now we are going to go ahead and create a hosted zone in AWS so that we can start using AWS Route 53 as our DNS zone. So for that, you can go to Route 53, create a hosted zone, and give your domain name, whatever domain name you are bringing, and then you can have publicly hosted and private. I am bringing a public hosted zone. once you create your zone, you will see two entries are created by default, that is name server and start of origin or authority of origin. And then I'm going to go ahead and create a record that is routes traffic to an IPv4 address. So you can create multiple type of a records, www, or just the bare minimum domain name. So here you can see I have created a www type of a record pointing to the EC2 server. And what happened at this point of time, once you create your zone, AWS is going to give you some of their name server, which you need to go back and populate at your original domain provider. So that's what I just did. As you can see, took all these AWS name servers and updated it to my domain provider and instructed them to start using these name server instead of their own for my domain. All right. By doing that, now we are trying to see if we can start using AWS DNS server for name resolution. And once that happen, ACM DNS validation should be complete. So give it some time because DNS propagation takes some time. So let's check back in 30 minutes. Here we are again. Let's try to dig this time and see who is answering this. Right now it is, as you can see, now it is started getting resolved by AWS DNS. So no more Dyn DNS but AWS DNS. That means our DNS is in effect. You can see it is been resolved by Amazon. Okay, so we are using Route 53 for our name servers, and let's see if it helps us for ACM certificate validation or no. So my server is responding, I can connect to it, and everything is looking fine at this moment. But as you can see, we can only connect to port 80 but not HTTPS, which is the goal of this video, to make sure that we enable HTTPS for our web server. All right, so here you can see this is our hosted zone. We have name server record and a couple of A records. Uh, but what we are missing is when you go to certificate manager and to do a DNS validation, you need to create a CNAME, which is provided by ACM, certificate manager. So we need to take those ACM and create those entries, this time in AWS hosted zone record. So we are still creating the CNAME entries, but instead of creating it at original domain name provider, we are going to create them at Route 53, and creating it in Route 53 very easy. You can just click that create in Route 53, and since Route 53 and ACM both are AWS entity, it will automatically create one for you. All right, here you can see our certificate is still pending validation. Let's wait for some time and go to Route 53. You can see we have the CNAME records created automatically. We have CNAME record created automatically. And at this point of time still says pending validation. Allow it some time because there is no way we can trigger the validation. It takes its own time. So here I am again. uh, Please check back in some time. So I put this comment, went back, got my coffee, came back after some time, and voila, you can see the status is issued now. So we have a certificate issued from AWS certificate manager. Can be used with CloudFront elastic load balancers, ALB, and even in API. So now we have AWS issued certificate, and this certificate is signed by AWS CA, which is trusted by most of the browsers. So the first step is done. That means we have a certificate. That, but can we download this certificate and use it in our web server? That's not the case here with ACM or AWS Certificate Manager. You can only use this with AWS component. And that's what we are going to do next. View all certificate. You can see that I have one certificate and the certificate identifier is there. I'm looking to import this, and import certificate, that means you want to bring your own certificate. There is no way. Actually, I was spent trying to see if we can download this certificate, but I realized that this is not possible. It's not like a certificate you are getting from your enterprise CA and you can use it with your application. No, it is only available for AWS services. And good thing is our web server is hosted in AWS, so we will just use this. These are the some options. Okay, now let's look at what we are going to do next. We will need to put your website behind a AWS ALB and create a HTTPS listener, right? So now, so we have certificate, but it can only integrate with ALB. So let's go ahead and create an application load balancer, put our web server behind that load balancer as a target group, and then we are going to apply the certificate. So here I'm going to go ahead and create an application load balancer, not the elastic load balancer, but application load balancer. Give it a name. This is an internet facing. We have only IPv4, and then do the network mapping. That means use the VPC where you have your web servers or where you want this ALB to live. Then pick up the availability zone where you are planning to put your web server. All my web servers are in public subnet, so I'm going to select East 2A and 2B because that's where web server I'm planning to spin up my web server if I need more than one for auto scaling purposes. Then you can reuse the security group or you can create a new security group. We are going to reuse the security group for our VPC, the default security group for our VPC. And then you're going to go ahead and create a listener. So a listener is a process that check for connection request using a port and protocol you configure. So I want my uh, um, load balancer to listen on port 443 and redirect it back to target group who are listening at port 80. So that's the whole goal. You create a listener and tie it to a target group, and target group is where your actual web servers are contained, or it's a group of your web servers. So I'm saying here this is the important field, default SSL or TLS certificate from ACM. I'm not bringing my own certificate. We're saying use ACM certificate, and the certificate you can select from your drop down. There are the rest of the other options. We are leaving it all default for the time being. Let me show you how to create a target group. So this is our load balancer and forward to a target group. And we already created a target group. Let me expand that. I know there are a lot of moving parts, so don't feel lost. Essentially, what we are trying to do, create a ALB and then create a target group. And within target group, what you do, you create your instance and say what, where or what port they are listening at. So my TEENT EC2 is listening at port 80. You add them as pending. So we have our target group and then we have our load balancer. All right. Let me show you the resource map and the things will be clear. Here you can see I have one listener that forward to a target group, and within target group today we have just one instance, and that instance is actually listening on port 80. Okay. So that's about it. We have our ALB, we have our target group, and ALB we already instructed during creating the ALB that use ACM and use the certificate what we just have in certificate store. So that is looking good, but how you are going to access that website using your ALB, right? You do not want any A record because certificate is only associated with ALB. So in this case, what we have to do, we have to get rid of the A record, what we previously created for one particular EC2. Now we are going to delete those and recreate new A records with ALB as uh, as actual value. So instead of our A record pointing to a particular EC2, it will point to ALB because that's what we want. We want anyone accessing my website should go to ALB, and ALB in turn should redirect it to the actual host. So here what we are going to do, we are going to create a new A record, and here you can see when I try to use ALB value, I'm getting error. So what is that error? Initially I didn't get it, that I want to create a www record. It's a type record, and in value I'm putting my ALB's ARN, but still I get some kind of like a error, uh, 400. So what is that? That was because you don't want to use the value directly, but you need to toggle this alias switch and then go and say that I want to alias to a application or classic load balancer. It lives in, select the region where it lives, and then you can go ahead and pick the actual ALB what you just created. So this is how you create A records with your ALB. And it was kind of like a tricky for me for the first time, but eventually we figured it out. So now we are going to create two A record just similar to what we had before, but instead this time we are pointing to ALB by toggling the switch alias. So I hope uh, this thing is clear to you. That means we don't want any record with actual EC2 server or our web server, but we want A record type pointing to our ALB. And that's what we have today. You can see our domain name is pointing to ALB for both the record types, www and the bare domain. And this is a internet facing ALB. So at this point of time, anyone should be able to use that domain name, and that domain name should resolve by route 53, and it will be resolved to our ALB address, and ALB address already has an HTTPS certificate applied to it. Hence you can see when I do a curl with HTTPS, now we can connect to port 443. That was our goal. Now our website is secure. You can see we have the padlock and it is verified by Amazon. We can click on more information to look at the certificate in detail. Here you can see view certificate, and this is my like 3 layer of that. Amazon as a root CA, then we have a sub CA, and finally the individual certificate. You can see we are using RSA 2048 as a key size, and all those typical certificate X509 version 3 information is available to see here. So with that, you have seen how to request a certificate and how to associate that certificate with your web server. But and that's solve our problem to make our website secure. All right, maybe HTTPS slash www or the bare domain is not resolving at this point of time, so we will check back in a few minutes and it should be fine. We have it just takes some time to propagate. Now you can see I just curled the bare domain and it is resolving properly. So with that, we have achieved our goal to how to use ACM to secure our website or application.